Hello everyone, welcome back to the World of Chemistry YouTube channel. Today we will discuss about the atomic models. In that we will see Thomson atomic model and Rutherford atomic model, atomic number, mass number, isotopes, isobars and isotones. We will discuss all these concepts. Now Thomson model of atom and Rutherford model we will discuss. So first we'll see Thomson model of an atom. So students, today we'll discuss Thomson model of atom. So remember that atoms are extremely small, so scientists cannot see them directly with their eyes. Therefore, they performed experiments and proposed models. A scientific model is simply an explanation of how something works based on available evidences. So here, two important models before the modern atomic theory were Thomson atomic model and Rutherford atomic model. So now let us see how these models were developed. First we'll discuss Thomson atomic model. So after discovering electrons through cathode ray experiments, Thomson realized that atoms contain negatively charged particles. However, atoms are electrically neutral. We have studied that. Therefore, there must be some positive charge present inside the atom. So what happened next? The Thomson made some assumptions. What he did, he talked about the atom is uniformly positively charged sphere. So the atom is uniformly and charged sphere. Next he explained electrons are embedded within a sphere. Okay, then positive charge and negative charges balance each other. Positive and negative charges balance each other. So that's why he said that the atom remains electrically neutral. We can consider this watermelon as an uh, electric atom, as an atom. So this is an watermelon. So this red portion we have is a positive charge, represents the positive charge, and these black seeds represents electrons. So this model is also called as a watermelon model. So what it explains here is, it explains the existence of electrons and also explains electrical neutrality of the atom. What he explained? Neutrality of an atom. So now, what is the limitation or drawback of this model is? I'll ask you one question. If positive charges, if positive charges spread throughout the atom, what will happen when fast moving particle pass through it? I'll repeat my question. So when these when this positive charge when this positive charge spread throughout the atom, what will happen when fast moving particles fast moving particles pass through it. So to explain this question, we have to study Rutherford's atomic model. Rutherford atomic model. Now, let's see how Rutherford model works. This is the experimental setup of the Rutherford's atomic model. So, Rutherford took a very thin foil. He took a very thin gold foil. This is a gold foil here, and then he bombarded it with the positively charged alpha particles. Positively charged alpha particles. He took a thin gold foil. He bombarded it with positively charged alpha particles. So what are the components we need here is alpha particle source. This is alpha particle source and thin gold foil. And third one is zinc sulfide screen. So this is the zinc sulfide screen. So what are the observations we are going to see here is most alpha particles, particles, the alpha particles passed, alpha particles passed straight through. So the meaning is here, the first observation was alpha particles passed straight through it. So what is the meaning? The meaning is most of the atom has empty space. The most of the atom remains empty space. That is the meaning of this statement. So what is the second observation? A few particles were deflected slightly. Few particles were deflected slightly. So we can see in the diagram, some went straight and some are deflected very slightly. What is the meaning of this is there is some positive charge inside the atom. The deflection in the particle shows that there is some positive charge inside the atom. So the observation number 3 is what the observation? Very few particles bounced back. So here some went straight lines, some were deflected, some were deflected. Here we can see the some rays are bounced back. So it was almost an incredible as firing 15-inch shell at a piece of tissue paper and having it come back and hit you. Okay, so meaning is that there must be a tiny dense positively charged region inside the atom. So the particles uh, bouncing back of the particles gives the meaning that it there must be some tiny dense and positively charged region is space region inside the inside an atom. So the conclusions were, so here we can see the observations were most of the alpha particles went undeflected, means in the straight line. So few particles were deflected by small angle and very few particles deflected backward, means bounced back. Now the comparison we can see here. So what conclusions gave the Rutherford models means presence of the nucleus. So it says there is a presence of nucleus, a tiny central region called the nucleus existence. Then the positive charge, the entire positive charge, the first one is okay, the first one is presence of the nucleus. The conclusions were presence of nucleus, the tiny central region where the called the nucleus exists. Second one is positive charge. Positive charge. So entire positive charge is concentrated on the nucleus, concentrated in the nucleus. Then the third observation is most mass. Almost all mass is concentrated in the nucleus, concentrated in the nucleus. Then the fourth conclusion was empty space. Empty space. So most of the atom consists of an empty space. So this is all empty space. The fifth conclusion was electrons revolve around the nucleus. So electrons revolve around the nucleus. Around the nucleus. Electrons move around the nucleus. So what was the merit and demerit? Atoms have lot of empty space. This is the conclusions. Atoms have lot of empty space. Atoms have positive charge entity. Positive charge entity is present as a dense mass. Also, almost all the mass is concentrated at the center only. So, the dense mass is very small and is known as the nucleus. So, size of the nucleus is 10 to the power of minus 15 meter. So, size of the atom is 10 to the power of minus 10 meters. So the comparison we can see. So positively charged mass is located at the center and electrons in the circular path. Electrons are in the circular path. So this is the nucleus. So positive charge masses are almost concentrated here. So now here the electrons are revolving around. The force is electrostatic force. So that what's happening due to the electrostatic force, it is holding together. So what are the limitations? Rutherford's model could not explain stability of an electron in an orbit. Okay, before going to limitations, we'll discuss some merits. What are the merits? Explain alpha particle scattering. He explained alpha particle scattering. Merits. He explained alpha particle scattering. And second merit is discovered the nucleus. He discovered nucleus. Then third merit is explain empty space in an atom. Empty. He explained the empty space in an atom. In an atom. So these are the merits. So what are the limitations? Suppose a fan is rotating and suddenly power is switched off. Will it keep rotating forever? So the answer is no. So according to a classical physics, a moving electron should continuously lose energy and eventually fall into the nucleus. Therefore, atoms should collapse, atoms should be unstable. So what was my question? My question was, suppose a rotating fan is rotating and suddenly power is switched off. Will it keep rotating forever? No. The answer is no. So according to classical physics, a moving electron should continuously lose energy and eventually fall into the nucleus. Because of that, there must be atom collapse, atom should collapse, atom should be unstable. But atoms are stable. Hence, Rutherford's model failed to explain the stability of an atom, arrangement of electrons, and atomic spectra. So then this so then this limitations led to the development of the Niels Bohr atomic model. So because of Rutherford's atomic model limitations, the new atomic model discovered, that is Bohr atomic model. Bohr atomic model. Okay. So the some comparisons we can see here is the how in the Thomson model the positive charge spread throughout the atom, but in the Rutherford atomic model we can see it is concentrated in the nucleus only. Okay, it is concentrated in the nucleus. So embedded electrons are embedded in the Thomson atomic model. Thomson atomic model. But in the Rutherford atomic model, the positive charges revolve around the nucleus. The electrons are revolve around the nucleus. So in the Thomson atomic model, there is no empty space, but in the Rutherford atomic model, there is a empty space. In the Thomson atomic model, there is no nucleus. So nucleus is absent in the Thomson model. In the Rutherford model, there is a presence of nucleus. So it is the Thomson atomic model is based on the electron discovery, but Rutherford's atomic model is based on gold foil experiment. Gold foil experiment. So the Thomson proposed that an atom is positively charged pair with electrons embedded in it like seeds in a watermelon. However, Rutherford's gold foil experiment proved that this idea was incorrect. Rutherford discovered that atoms have a tiny, dense, positively charged nucleus and that most of the atom is empty space. Although Rutherford's model explained the structure of atom better way, it could not explain why atom remains stable. So this problem was later solved by Bohr atomic model. So this is all about the Thomson atomic model and Rutherford atomic model. Now we will discuss about the atomic number, atomic mass, isotopes, isobars. We'll discuss. Okay.